Hey folks, in the previous video, we started looking at what are some of the optimizations, gas optimizations that you can do while writing a Solidity smart contract. So let's continue that and take a look at some of the ways to optimize gas. We've already gone through the first 6 ways, and now let's start from the seventh one. Now the seventh one is use custom errors to save deployment and runtime costs in case of revert. For example, instead of using strings for error messages, you can use custom error messages like this to reduce both deployment and runtime gas costs. So this revert keyword, right? It's not very frequently used when it comes to Solidity, or at least I haven't observed it. However, this can be a very useful play to reduce your gas costs, as instead of using strings, what you're doing is you are creating your own custom error saying that this particular variable is unauthorized, this particular action is unauthorized, or whatever, right? So you can do that, and then you can save on gas fees, because here you can reduce both deployment and runtime gas costs. So, and also you can pass dynamic information to to the user regarding whatever the error was. Now, the next one that we are going to look at is refactor a modifier to call a local function. So, for example, this is our modifier only owner. In this case, we are going to check if the owner is equal to message.sender, and we are calling this function called owner, or referring to this variable, for example, right? Instead of this, we can modify this to call a local function which is going to use the required variable. So this saves bytecode size and thereby deployment cost, because whatever you are going to deploy, it is also going to depend on the final compiled bytecode size, right? So because modifier code is copied in all instances, it increases the bytecode size. By doing a refactor to the internal function, you can reduce the bytecode size significantly at the cost of one jump, right? One jump instruction. So this is only if you are constrained by bytecode size, that is, you have too many lines of code, and there is again one of the popular EIPs that restricts you to have only some X amount of bytecode size, right? So in case you are running into too many functions, too much code, this can be one way for you to be able to optimize on your costs, right? Use indexed events, as they are less costly compared to non-indexed ones. Yet again, indexed events are highly recommended, not just because they can save the gas costs, but also you can understand and get more data from the event logs themselves. That's why I highly recommend to use indexed events. However, you have to keep in mind that indexing bytes and strings, right, like dynamic tables, are more expensive than their unindexed version. So you want to index your uints or your addresses and things like that, which are more of fixed in nature. Use struct when dealing with different input arrays to enforce array length matching. So when length of all the input arrays needs to be the same, for example, you have over here, say V, R, and S, all of these are bytes 32 arrays. You, instead of saying, instead of checking the length, you can actually use something like a struct, and then you can make sure that that the sizes are as expected, right? So that's basically one of the ways to save. You don't have to manually validate the links, right? You can save on that. And then provide methods for batch operations. So this is again a very underrated but a very very cool optimization, where you can provide the method for batch action to users. Instead of them doing the same action and calling it again and again, you can provide a method that can help do the same thing but in batches to the users, and this can be extremely efficient for you in case your contract or your functionality, your DApp, deals with situations where users have to perform batch operations. So instead of doing something say once, you can also provide them the ability to batch do something like batch mint NFTs or things like that, right? That is that's a huge lifesaver. Now you have shortcut with or and operators. So the second case in this is not checked if the first case gives the result of the logical operation. So we can put the lower cost expression first, so the higher cost might be skipped, right? This is something that is generally an advice in programming languages itself. So yeah, that's that. You can also take a look. There are also some general rules that optimize for common cases versus rare cases, because when optimizing for rare cases can increase your gas costs for all the other cases, but you should try and optimize for common cases first. And then runtime cost is greater than deployment cost, right? Deployment costs are one time. However, every time you're going to run particular functions, you're going to keep calling those functionalities, and users are going to keep paying gas. So runtime cost is definitely, think about it, more than deployment cost. User interaction is most common, more than admin interaction. Of course, admin interaction is going to be limited, so make sure that you optimize for user interaction. There is also another link that I've linked in the tutorial, which is gas numbers every Solidity dev should know. This is a very, very interesting sort of, lay of the land in front of us in terms of how the contract calls are priced. You can see that what is the price, what is the gas usage for these contracts in terms of actions that are happening, like deposit action. And then there is, you can see the deposit action on Tornado Cash is really huge, because it uses zero knowledge proof, so it switches from one layer to another, etc. So this is just to give you like a good idea, and you can yourself compute this for your own contracts, because at the end of the day you will have the bytecode, you have these operations that are actually in the form of opcodes. So at the end of the day you can always compute a rough usage for your own contracts, for your own functions, etc., right? And this can be something cool that you can keep for yourself as well.